Domain, set of all x values for which the function is defined, the input. So people in mathematics may talk about what's the domain? What are your inputs? What are your x values? The range, set of y values that are defined for the function, or the output. So y values, range, outputs. That's kind of one of the things that makes math confusing is that you walk into my classroom and maybe I really like to use the word domain and range, and some other teacher always talks about inputs and outputs. I mean, we're all talking about the same thing, it's just we're using a different word. So, the easiest way to discuss range and domain would be to draw a picture. So what kind of graph is 1 minus 2x squared? Parabola, U-shaped graph, shifted up 1, and what's the negative 2 going to do? It's going to point it down and stretch. So it might look something like this. Now you certainly can go into your graphing calculator and have it draw a picture for you. But this point right there is 0, 1. So if I'm going to talk about the domain, what x values are represented whenever you draw a U-shaped graph? Do we have any restrictions? What's that?
That's the kind of x value.
I want a range of I want, like interval notation. From what x to what x am I allowed to use in this function? Is there a number when you look at 1 minus 2x squared that you know you can't use? Can I plug in 5? Can you plug in 5?
No.
Is there anybody in here who can't square the number 5? Can you plug in negative 5? Can you plug in 100? Can you plug in negative 100? Can you plug in 1 million? Can you plug in negative 1 million? So is there any x values that you can think of that you can't use in this problem? No. So my domain, different ways of writing it. Some of you will write negative infinity to infinity, parentheses on both, can't use square bracket. Some of you might write all reals. So in other words, all real numbers can be used. But the idea is we see parabolas as these U-shaped graphs, and every time we see one, it stops right there. And so our brains start to think, oh, like negative 10 to 10 is the only x value I can use. But these graphs continue to widen out forever, right? If I kept zooming in, I mean, it just stretches forever. It keeps going down and left and right. So everything can be used. How about the range? The range now, we're talking about the y values. What y values are represented by that graph?
1.
Just 1? Y value of 5. Do I have a y value of 5 on that graph? No. Negative 5? Positive 10. Negative 10? So what y values are being represented by that graph? Y's that are less than or equal to 1. So the y value of 1 is the largest, but anything underneath it. Other people might say negative infinity up to 1. So they would start at the bottom of the graph and they work their way up. All these y values, even though they're not, we can't extend the graph forever, but they're here all the way up to a 1. So that's domain and range. Okay? You can let me do it and watch up here if you want. Divided by, what's the bottom? X squared. The denominator?
2x.
2x squared?
No, x squared minus 2x.
Here we go. X squared minus 2x. Okay, so that's, so when you go to graph it, you get this thing that, yeah, it kind of looks like a volcano. But it does seem that there's some space between them. So somewhere, we're getting some other values. And if, where's my window? Window. I'm going to drop a little further down and see if I see it. So we have kind of up here above the x-axis, you have that volcano look to it. But you do have this U-shaped graph in the middle. I don't know, something like that. So let's talk about the domain. What x values are we allowed to use in this problem? What x values are we allowed to use? So I take the denominator off to the side. It's x squared minus 2x. I do my factoring, so I can pull an x out of each of those terms. I'm left with x and x minus 2. So I set the x equal to 0 and I get x is 0. I set the x minus 2 equal to 0 and I get 2. Why are those two values important in this problem? They make they make that bottom 0, right? We can't divide by 0. So they're critical values because it's undefined. And that's why I should really not, this one should be more like this. So where those two graphs come up against what we call vertical asymptotes, they're sitting at 0 and 2. So my domain some of you might write it like that. You might say it's all the real numbers where x is not 0 or 2. You can use everything else in this problem. But if you try to plug in a 0 or 2, you're going to have a problem. Or you might say negative infinity up to 0, but don't use it. Everything between 0 and 2, and 2 to infinity. We're going to skip the range on this particular problem. We don't really have to do range ever, but the gap is above 0, and I believe that parabola at the bottom that sits in between goes up to like negative 20, hits negative 20. So it'd be anything above 0 for y's and anything below negative 20. Okay, let's look at these two graphs. Now remember the square root graph? The square root graph looks like that. Square root of x. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. You can plot those points out. What's going to happen when you do minus 3 inside the square root? So which way does it shift us? To the right, 3. So we're going to go 1, 2, 3 to the right. And we're going to get a graph that looks like this. So according to that green line, what would be your domain? Do I have any x values over here? They don't start until 3. X that's greater than or equal to 3 is one way to write it. Or you can say 3 with a square bracket. All right, the arrow keeps going way out to the right forever, so infinity. But actually in P4, P5, we learned how to solve those. What should you do when you're running into a square root? Take what's underneath it and set it greater than or equal to 0. Add the 3 to both sides. Right? That will ensure that, or that tells me the domain. Take what's underneath the even root, set it greater than or equal to 0, and solve it. D, is the 3 under the radical or is it outside the radical? So what does plus 3 do? Moves us up 3. So where do my x values start? Maybe you take what's under the square root and set it greater than or equal to 0. You look at the graph. The domain on this problem is an x that's greater than or equal to 0. Or an interval notation, 0 to infinity. Let's quickly go back here just for practice. Go back to this green graph. What's your range? What y values are being used in this problem? Anything below the line? What y value is this? And up, right? So you might say y's that are greater than or equal to 0. Or from 0 to positive infinity. 0 for the y value to positive infinity on the y-axis. How about the range over on this problem? Y's that are greater than or equal to 3, or maybe a square bracket 3 to infinity.